Welcome friends, welcome you all in my channel Chemistry and History of Molecules. I am Tanmay. So today we will discuss a practice question. That question may be useful for CSIR-NET, GATE, JAM, etc. exams. So the question is, which of the aromatic compound is most resistant to oxidation? So I always suggest that try to understand the actual question asked in the paper, because sometimes questions are masked by something else. So it is essential that if you understand what is actually they want to know, then it is easier for you to answer the question. So initially I will explain the story, means with logic, and at the end I will explaining the trick how to solve this question within 1 minute. Okay, let's start. Now the question is written, which of the aromatic compound is most resistant to oxidation? So at the beginning, let's write the structure of the compound. Here the options are given: benzene, naphthalene, anthracene, and all other aromatic. Here the options given: benzene, naphthalene, anthracene, and all are equally resistant. Okay, let's see. So this is benzene, this is naphthalene, and this is anthracene. Means 1 unit of this increase of benzene ring. Okay. What is the background of asking this question? The background is all are aromatic. Aromatic compounds are highly stable, so they are reluctant to destroy their unstability which arises due to oxidation. That's why they want to know the comparative reactivity of these three, or on the fourth option, equally resistant. So to explain that, we need to know the resonance energy of this. So resonance energy of benzene is 36 kilocalorie per mole. This is 61 kilocalorie per mole, and this anthracene is 84 kilocalorie per mole. And at this context, I will tell you the resonance energy of phenanthrene. You should remember, phenanthrene is this molecule with 92 kilocalorie per mole. Okay, keep this information in mind for value. Try to keep it in mind. Question may come. So 4 are given. Now, if benzene is oxidized, so a big amount of resonance energy will be lost. For example, 36 kilocalorie per mole. But if naphthalene oxidized, it may produce let me write here. Naphthalene will produce, means one ring will be oxidized. So if one part is oxidized, means from here, then one benzene is there, so that stability is retained, and so it should produce this. Okay, oxidation. So now, right now, it is also have 36. Actually, the value exactly not 36, but for comparative study, we will consider like that. Okay. If this molecule oxidized, then what could happen? Generally, what happens, that this oxidizes here, the in-between ring. Why? Because this is 36, this is 36. Okay. So overall, so this is 36, overall is 72 overall. So previously it was 84. Now loss is 84 minus 72 equal to 12 kilocalorie per mole. Let's consider the another option. Another option means, for example, this like naphthalene, one side is oxidized. So this naphthalene RE is around 61 kilocalorie per mole. This is all our rough value for understanding. Here for comparison, only memorize this naphthalene, benzene, anthracene, phenanthrene, but not this. 61 kilocalorie per mole. So right now resonance energy means previously loss is this, and right now loss is 84 minus 61. So 323. So we can see if oxidation happens in this terminal ring, then loss of RE is more compared to this middle 9 and 10. RE is less. So similar thing, if you can consider, like I have told here about this benzoic acid, instead of that it could be this naphthaquinone also. Means one side naphthalene ring, quinone. Here also similar story, means one side is loss. So means what they wanted to know, that which of the aromatic compound is most resistant to oxidation. So in case of naphthalene, loss is 61 minus 36. So equal to 25. Okay. And in case of naphthalene, loss is 25. In case of phenanthrene, loss is 12 or 23, but that path will be favored or followed which is associated to the lower energy of activation or loss of minimum resonance energy. Okay, so here minimum. So the ultimately first minimum is 12 for anthracene, second is naphthalene, and third is benzene. So this option is invalid. All are equally resistant. No, they all are not equally resistant. So this is gone. Now question is 3. So from resonance energy calculation, anthracene is first, second is naphthalene 3. So they are not equally. And which of the aromatic compound is the most resistant to oxidation? The answer is this. Anthracene is most resistant. I made mistake. Most resistant is benzene. Most active is anthracene. Okay. So this is actually the end of the main answer discussion about this question. Now I will explain about the tricks how to solve this question within 1 minute. So when you have this question, which aromatic compound is most resistant to oxidation, then you first of all you need to remember the values. Then you can, and another thing, you need to know the structure. And if you know this, you know benzene is one aromatic ring. So loss of RE means total RE gone. Here naphthalene 2, 1 gone, so 1 is there. And in anthracene 1 gone but 2 remaining. And another thing, you should remember this thing, that anthracene always prefer to react in 9-10 position. What do I mean 9-10 position? This is 9-10 position. So generally anthracene prefers to react at this position. Even if you do dill solder also, these two position. Naphthalene reacts, anthracene reacts. So this is. Now a real practical application or real proof about this concept. For example, this naphthalene is industrially oxidized. Industrially utilized to oxidize to prepare phthalic acid. Okay, phthalic acid. And for that purpose they use V2O5 as a catalyst and oxygen as an oxidant to prepare. and this is produced. So this is the proof of the concept that one ring is oxidized. Okay, and so actually the answer is not phthalic acid, it is phthalic anhydride, because when they are closer together, so it eliminates water to form this anhydride. Okay, so okay, so this is the end of the discussion. So if you like my teaching, please press the like button and share this video among your friends, that many people could be benefited from my effort. And please subscribe my channel Chemistry the Mystery of Molecules and press the bell icon to get the notification of every new single video I upload. So let's see you in the next video.